Hi student, welcome back to PHY260. Chapter 4 about sound wave. Today we'll discuss part 4 of the chapter, which is Doppler effect. Example and solution for 4.4 Doppler effect. Example 7. A police car initially at rest emits a siren with a frequency of 1000 Hz. A criminal car is moving towards the police car with a velocity of 33 meters per second. Calculate the apparent frequency heard by the observer in criminal car. B. If the criminal car is now moving away from the police car, calculate the apparent frequency. Solution. Highlight the important part of the information, which is 1000 Hz of frequency. Velocity is 33 meters per second. Calculate the apparent frequency. And the police car is at rest. So when the police car is at rest means the sources is now at 0 meter per second. The sources is not moving, it's static. But the criminal car is moving towards the police car. So what do you think? What do you think the frequency of the observer heard? Of course, when observer approaching a sources, of course, he will hear a larger frequency. Using the same equation, f prime equal to f in a bracket v plus minus v naught divided by v plus minus vs. So the vs is cancelled equal to 0. So we're going to focus on v naught. So what do you think your v naught will be? To get high frequency, v naught must be positive. Substitute the information that you have, which is 1000 for frequency, in a bracket 343 plus 33 divided by 343, and you will get 1096 Hz. So 1096 Hz is larger than 1000 Hz. Next, if the car criminal is now moving away from the police car, calculate the apparent frequency. So, the police car still at static position, but now the observer is moving away. So what do you think the observer will hear while it's moving away? Of course, he will hear a lower frequency. So to get a lower frequency, the V naught must be negative. So substitute the value that you have, therefore your frequency is 904 Hz, which is lesser than 1000 Hz. Example 7b. C. The criminal car is now in stationary position. The police car is moving towards the criminal car with a velocity of 33 meters per second. Calculate the apparent frequency heard by the observer in the criminal car. D. If the police car is moving away with a velocity of 33 meters per second from stationary criminal car, calculate the apparent frequency heard by the observer in the criminal car. Solution. Highlight the important information. The criminal car is static, so the observer now is static, but the police car is moving, so which means the sources is moving. The same speed, 33 meter per second, and the same frequency, 1000 Hz. So to answer C, we're going to use the same equation, F equal to F naught, F prime equal to F in a bracket, V plus minus V naught divided by V plus minus Vs. So for the V naught is 0. So what do you think the observer will hear if there is a source moving towards him? Of course, he will hear a higher frequency. So to get higher frequency, the denominator must be smaller. As to have a smallest denominator, your Vs must be negative. So plug in all the information that you have. 1000 times with 343 divided by 343 minus 33. Therefore, you get 1106 Hz. So 1106 Hz is larger than 1000 Hz. Next, for D, if the police car is moving away, which is the source is moving away, and the observer remains static. So we're going to use the same equation. V naught is equal to 0. V observer is equal to 0. Okay, but if you want to get a lower frequency, because the sources is moving away, of course, the observer will hear a lower frequency. So to get a lower frequency, the denominator must be larger. To get a larger denominator, your Vs must be positive. Substitute the information that you have. Therefore, your F prime now is 920 Hz, which is lesser than 1000 Hz. Let's try example 8. So this example 8 is about Doppler effect and reflection. So there is two types for this question. So let's look at the question. A 5000 Hz sound wave is emitted by stationary source. The sound wave reflects from an object moving towards the source. What is the frequency of the wave reflected by the moving object as detected by the detector at rest near the source? Solution. Highlight the important part, which is 5000 Hz. Stationary source, the wave will reflected, the source, the object is moving. So this is the figure. The original sources is static. The object now will become the observer. It will listen to the frequency produced by the original source. Step 1. object becomes the observer before it reflects. So Vs is equal to 0. Using the same equation, f prime equal to f in a bracket v plus minus v naught divided by v plus minus vs. So when an observer moving towards the source, of course, the frequency heard will be larger. So to get a larger frequency, the v naught must be positive. So substitute the information that you have. 5,000 in a bracket 343 plus with 3.5 divided by 343. So you get 5,051 Hz. So it's not finished yet because we want to know what is the frequency heard by the detector, and the detector is near the source. So for step 2, object now will become the sources because it will reflect the frequency produced by the original source. And now the observer is static, is not moving. The source is the one that are moving, which is 3.5 meter per second. So using the same equation, f prime equal to f in a bracket v plus minus v naught divided by v plus minus vs. So the v naught is now 0. The observer is now 0. The detector is 0, is not moving. So the observer is equal to 0. So we're going to focus on Vs. So what do you think your Vs will be? Positive or negative? Look at the figure. If the source is moving towards an observer, of course, the observer will hear a larger frequency. So to get a larger frequency, the denominator must be negative or must be smaller. So your Vs is negative. So substitute the value. But now we are not going to use the original frequency 5,000. No, we are not using the 5,000. But instead, we are using the f prime for step 1, which is 5,051. Substitute the 343 divided by 343 minus 3.5. Therefore, you get 5,103 Hz. Recent usage of Doppler effect. So Doppler effect currently being used to detect the signal of an airplane. So for example, the antenna will provide signal to the airplane and the airplane will reflect back the signal. So the frequency heard or the ping produced by the airplane will detect the position of the airplane. So when during the time MH370 were missing, what happened is there is a ping located until a position where the plane started to missing. So once the plane missing, there is no ping or frequency produced from the airplanes. Another application of Doppler effect is being used by animals such as bat. So bat will produce this frequency, and the frequency will reflect the prey, and the prey will provide the information to the bat. Thank you for listening. Hopefully you get some information from this video.